Welcome back to Digit Tutorials. Today we're going to be discussing factoring in general. We will find the common factors and the difference of two squares. Common factors. Recall that the greatest common factor of two or more numbers is the largest number that is a factor of or will divide evenly into each. For example, 5 is the greatest common factor of 10 and 15, since it is the largest number that divides evenly into both. First, we will look at the greatest common factor of two numbers. Find the greatest common factor of 24 and 18. We know that the factors of 24 are 2 times 2 times 2 times 3, and the factors of 18 are 2 times 3 times 3. Note that the greatest common factor is 2 times 3, as both 2 and 3 are common in both numbers. Therefore, if we say 2 and 3 times each other, it will be equal to 6. Therefore, the greatest common factor of 24 and 18 is equal to 6. We can extend this concept to find the greatest common factor of two monomials. Find the greatest common factor of 12ab cubed and 6a squared b. The factors of 12ab cubed are 2 times 2 times 3 times a times, b times b times b. The factors of 6a squared b are 2 times 3 times a times b. Therefore, the greatest common factor is 2 times 3 times a times b. Since 2, 3a and b are common within these two expressions, then the greatest common factor is 6ab. To factor a polynomial is to express it as a product. Factoring is the inverse operation to expanding. When factoring a polynomial, the first step is to find the greatest common factor of each of the terms. Factoring the differences of two squares. The product of two binomials where one is a sum and the other the difference of the same two terms is called the difference of two squares. The difference of two squares in algebra refers to an expression of the form a squared minus b squared, where a and b are any two numbers or variables. It can be factored into a plus b, a, b. This means that any expression where one perfect square is subtracted from another can be simplified into the product of the sum and difference of the square roots of those terms. Key aspects of the difference of two squares. Structure. The expression always involves two terms, each being a perfect square, a number or variable raised to the power of 2, and separated by a subtraction sign. Factoring. The expression a squared minus b squared can be factored as a plus b, a, b. This means that when you multiply a plus b and a, b, you get a squared minus b squared. Application. This pattern is used to simplify algebraic expressions, solve equations, and is fundamental in various mathematical concepts like factorization, quadratic equations, and beyond. Example. Consider the expression x squared minus 4. This is a difference of two squares because x squared is the square of x and 4 is the square of 2. Therefore, it can be factored as x plus 2x, 2. In summary, the difference of two squares is a specific algebraic pattern that can be recognized and factored into the product of the sum and difference of the square roots of the two terms. Thank you for joining us today. Please share if you find this useful. See you next time.